Hello everyone, this is Abhinava Kalita.
This is Abhinav Kalita.
And this is Ambarish Burman.
We are from Delhi Public School, Numaligarh, Assam. We study in 10th standard. Today we would like to present before you Project J.A.R.V.I.S made for ATL Space Challenge under the topic Explore Space Robotics.
Meet Jarvis, an artificial intelligence humanoid robot who loves space exploration. We have kept the name Jarvis because it is just a rather very intelligent system. Problem statement. It is taking a lot of time for space science in India to develop. Other countries are making extraordinary development. Example, NASA has already sent 2 rovers on Mars and ISRO's rover Pragyan unfortunately could not get established on Moon. It has been 52 years since man first stepped on Moon and ISRO has not yet launched any astronaut. The plan of launching astronaut has been postponed by 1 year with the announcement of Chandrayaan-3. It is clear that India has still not been able to explore the whole moon properly.
A big concept. Proposed solution: an artificial intelligence humanoid robot that we plan to send to space. The idea is that we will build an AI human robot that can be controlled by gesture control from Earth. Information transfer can be radio signals or quantum entanglement signals, which has been achieved by China by just splitting photons.
Objectives. Now, this will do two main jobs. Firstly, it will be like rover Pragyan and will accomplish all its objectives with artificial intelligence. Now, we know that rover Pragyan could not get established on Moon. That's why we aim to build Jarvis in such a way that it accomplishes all its objectives. It will collect and click pictures, analyze them, analyze soil samples, water samples, air samples itself with or without real-time guidance from Earth. After that, it will send the reports to the Earth instantly by RF or quantum entanglement signals. The second job it will do is to give training or simulation to astronauts. Astronauts will be kept in space-like conditions along with VR goggles that will connect directly to the camera of our robot on the moon. The gestures and voice commands of the astronauts from Earth shall be received by the robot on the moon, and the robot will copy the gestures and listen to the commands given from Earth. This is the 360-degree view of our 3D model. So here are the components of Jarvis. Firstly, we have the SuperCam, the idea of which we've taken from the rovers built by NASA. SuperCam is a camera, laser, and spectrometer that analyzes rocks and soil samples. Following that, we have the MastCam Z and the NavCam, the main job of which is to take high definition video of panoramic color and 3D images of the moon surface and features of the atmosphere with zoom lens to magnify distant targets. The third feature we have is the MEDA, which is Moon Environmental Dynamics Analyzer. And this device will basically measure the weather and dust in the atmosphere of moon. Following that, we have the main feature, which is the pixel, alternative of which is the apexes or lips. Now, pixel expands to a planetary instrument for X-ray lithochemistry. The main job of pixel is that it can trace microscopic life, it can scan rocks with X-ray, it can detect chemicals presence, its quantity and distribution on the surface of moon. Alternative of pixel is the apexes or lips, which were taken in the Pragyan rover. Uh, the robot will be powered by solar cells, which will be attached to the chest of Jarvis. It contains two antennae, which is attached to the robotic arms. Jarvis also contains cameras in cameras in his hands, which are helpful because when Jarvis will bend to collect soil samples, this camera will give us a clear idea of what is happening at a closer level. The backside of Jarvis looks something like this. It has a camera to monitor the back side of Jarvis. Supercam and MEDA is what we've already discussed. Now, these instruments are held together to the main body by the arms, or robotic arms. We then have the brain of Jarvis in the head, which is nothing but artificial intelligence code to help run the robot. Jarvis is also attached to a lab cum sample storage, which is attached to the back of the robot, which will help in which will contain specific chemicals for on-ground testing, along with along with providing space for storage of soil samples and other stuff. The chest of Jarvis is an openable chest, uh, inside of which are suspensors, temporary storage, and quadcopter and batteries. Suspensors help everything to be protected. Temporary storage, the soil samples which Jarvis collects can be stored somewhere inside of his chest. We also have a quadcopter for surveillance of the moon surface and batteries to power up the robot. Jarvis comes with microphone and speaker that makes it a perfect assistant for astronauts. So astronauts can directly communicate with it using natural language, and the artificial intelligence code, which is NLP, has been done by us, and we'll show you a demo in a bit. Jarvis contains motors which help it in locomotion. In total, it contains 11 cameras, 2 antenna, 1 quantum entanglement system, 25 motors, 1 microphone, 1 speaker, 1 quadcopter, 2 storage, 1 on-the-spot lab kit, solar cells and batteries, alternate of which is an RTG, which expands to radioisotopic thermoelectric generator, which had been used by NASA in its rovers. It also contains 1 weather or temperature analyzer. Then it contains the pixel or apexes or libs. Any one of them can be used. It works with AI. AI is used for roving, and more specifically, the reinforcement learning algorithm inside of AI is used. It helps in astronaut training and simulation, and it is also a very smart assistant, which is built by AI. The branch of AI that helps in building this assistant is NLP, or natural language processing. How does it work? This works in 2 ways. First of all, like any rover, so like the Perseverance rover or the Mars rover or the Pragyan rover, it will automatically, using the AI code which is already put into it, using that code, it will rove the surface of the moon, and it will collect soil samples, pictures, analyze traces of water, and also air samples automatically. The second method by which it works is through instructions given from Earth. Astronauts, as said, will be in a space-like conditions with VR goggles that will connect directly to the camera of Jarvis. This will help our astronauts to give a space-like feeling, and they'll also be more able to train themselves by the conditions in space. Here's a quick demo. Firstly, this is how the VR preview of the VR goggle preview should look. Now we've made a virtual environment, and we have made this using Unreal Engine, which is a game developer engine, but we have used this for our purpose. Now suppose this robot which is running is nothing but our Jarvis, and the camera view is nothing but the camera view from the real robot that should be on Moon. We have created this virtual environment of Moon as an example of the VR goggles preview that the astronauts will get when they are doing the simulation or training program. So as you can see, astronauts can ask the robot to move anywhere and the robot can perform any gesture by following the gestures of the astronauts from Earth. Next up, we have another preview of the NLP system, or the natural language processing system. Now, in this preview, you will see that how I'm interacting with the AI, with the brain of Jarvis, using natural language, and how I'm asking it to perform specific jobs.
Okay, Jarvis.
Listening, sir.
What is the progress?
All parts are working fine.
Jarvis, what is the date and time in your system?
September 29th, 2021. 11 hours 15 minutes 15 seconds.
Jarvis, move to the base camp.
Moving to base camp.
Jarvis. Okay, Jarvis, turn 180 degrees to the right.
Moving right.
Jarvis, move front.
Moving front.
Jarvis, jump.
Jumping.
Jarvis, turn right by 180 degrees.
Turning right by 180 degrees.
Jarvis, stop.
Stopping.
Jarvis, open chest.
Opening chest.
Release your quadcopter.
Releasing quadcopter.
Jarvis, what's the configuration?
All parts are working fine.
Jarvis, turn to the base camp.
Moving to base camp.
Next up, we have a code for gesture control. Now, in the bottom right, you can see the code which we have written by ourselves. That is the code for gesture analyzer or gesture sensor. Here is the video preview of the same. As you can see me there, so in my place, there will be an astronaut, and the program will basically monitor the gesture of the astronaut. Now, if it finds that the gesture is relevant to the robot, it will ask the robot Jarvis on the moon to perform the following gesture as it is. This is how the robot can be controlled from Earth. Now you will see a live implementation of all the three aspects put together.
Okay, Jarvis.
Listening, sir.
What is the progress of your body parts?
All parts are working fine.
Jarvis, what is the date and time in your system?
September 29th, 2021. 14 hours 9 minutes 32 seconds.
Jarvis, turn to the base camp.
Moving to base camp.
Stop.
Stopping.
Jarvis, turn left by 90 degrees.
Turning left by 90 degrees.
Jarvis, move front.
Moving front.
Stop.
Stopping.
Jarvis, turn right by 180 degrees.
Turning right by 180 degrees.
Jarvis, move to the base camp.
Moving to base camp.
Stop.
Implementation. This robot can be built all by ourselves using the resources provided by the ATL labs, like 3D printer, Raspberry Pi, cameras, solar cells, RF transmitters and receivers, motors, some devices like spectrometer and sensors, sensors like moisture, magnometer, accelerometer, temperature, etc. But this would not be practical for a space mission. To make a practical model, we need a lot of resources that we believe we can make up with by being in touch with ISRO.
So this was the idea for prototype. We hope to make amendments in future, and we also hope to make the model practically. Hope you like it. Thank you.